This presentation looks at the Windows Workflow Foundation, which is part of the .NET 3 framework. In it, we'll look at sequential and state-based workflows. So what is it that the Windows Workflow Foundation has in it? Well, basically, it has sequential workflows, as we'll see, but we can also design with state-based. Some workflows, as we'll find, are useful for sequential if they are well ordered and we know the basic sequence, where other ones are more ad hoc and are more matched to state-based machines. Along with this, it gives us a common workflow technology infrastructure. As we'll see, we can have a workflow runtime which we execute whenever we have a workflow. And also we can have a process-oriented viewpoint on software development, where we can actually design at a high level and define the basic processes that we can see within inside our application. The traditional way of coding is that we write code, we declare classes and methods, and then we create instances of objects using these classes. And then we can call methods within inside each of these instances. What we end up with is typically code, and a problem with this is that we tend not to have an overall schematic that we're actually working with, so that the actual design and abstraction is often divorced from the actual implementation of the code. Workflow has a different type of methodology. Basically, we create a number of activities. These are typically standalone activities which have a beginning and an end. They might be repeated many times, but we can fairly well script the actions of the activity and are typically goal-orientated. For this, we can create either a sequential flow or a state-based workflow. And then we end up with a high-level schematic of how all these activities fit together. This, from a business point of view, is much better in that most business people understand this type of methodology, where coding can obviously hide away much of the processes that are actually occurring within inside the application. So a sequential workflow might be to order a pizza. So we have a starting point and then we have an end point. So the first point in our sequential flow might be, are you hungry or not? If not, then we end. If we are hungry, then we could pick up the phone, then dial the number, wait for an answer. Does the phone answer? No. Okay, we'll redial the number and go through this loop until there is an answer, at which we can order our pizza. On the other side, the sequential workflow would be to take the order. Is the order acceptable? If it's not, then we might end. If it is, get the ingredients, make the pizza, put it in the oven, get the pizza out the oven, send it to a delivery person, then hand over the pizza, and then we get to an end. So we can see here that this is very much scripted and that we know the actions that are involved. Unfortunately, this type of workflow does not take into account any changes in the actual workflow. So it could be there is no dial tone here. So if we don't check for that, then we might actually go through the workflow but not actually check for something. A state-based one is typically used where there are possible changes in the flow and when the main states are defined. So in this case, we've defined a number of states. The user is hungry, order a pizza, reorder a pizza, take an order, make the pizza, deliver the pizza, and hand it over. And then how we move between these states are caused by certain events. So the user is hungry. Does he want a pizza, or does he want another type of meal? In this case, the event is pizza's wanted. So he might move into other states if he wants other types of food. Then he goes into the order pizza state, and it's up to us to define what happens inside that state. Then, if there's no answer to the order, then they will go to reorder a pizza. If there is an answer to the call, the event that happens is to then go to the take order on the other side. But when reordering, if there's no answer, then we will just give up, and then that's the end of our workflow. So the workflow on this side is to basically order the pizza. On the other side, we take the order. Has the order been successful? If not, we can have another event which ends the workflow. We can then make the pizza. When the pizza is ready, we create an event called Pizza Ready. We deliver the pizza, and eventually the event is we find the address and hand it over. If we don't find an address when we're delivering the pizza, we might get rid of it, and then we end again. So we can see here the state-based approach actually makes it easier for us to design a workflow which can change. So the ways that we can create our workflow is that we can have a basic console application, as we'll see, and we can also have a sequential and a state-based workflow console application. Workflow also integrates into SharePoint 2007 in that we can create our console application, either sequential or workflow, and then we can actually integrate it inside SharePoint. Another way that we can do it is to create a workflow library, which will typically create a DLL, either for sequential or state-based, and then we can have a Windows interface, we can have a web interface, and so on, which can call up the DLL. This has the advantages that we can create standalone workflow DLLs which can be called by any application. When we select our workflow initially, we select from the projects that we have in workflow, and then we can either select a library, a SharePoint 2007 machine, or we can go for a console application. And basically, the workflow architecture is built around 3 different layers. At the top layer, we have the basic workflow model in which we run our workflow elements. So it might be order a pizza, might be a workflow, deliver pizza, and so on. So these have the basic rules for creating the workflow. These are typically defined in XML. We can have the workflows themselves, and then any built-in activities to this layer and any custom ones. Basically, when we run a workflow, we run it within a runtime environment so that we typically execute the runtime environment and allow the workflow to run within it. And in here, we have our tracking, the basic rules for workflow, and any scheduling that we have. It also manages the activation of workflow and the states involved. At the core layer, we have the hosting layer, and with this we can have timers, the tracking of workflows, multi-threading, the communication, and so on. So what we typically do is that we run our workflow engine, and in this case we create a workflow runtime instance here. We can then add an event, so when the workflow is completed it will go to this event routine and we can start it up, after which we can then run our workflow inside the engine that we've actually defined here, and we create a workflow instance of our namespace and then also of our class. So this might relate to a DLL that we've created, and that will run within a certain namespace. So in this way we start up the engine and then we add the workflow into that engine and create an event routine to be able to capture when the event has started or has completed. So let's look at sequential workflow. In this part of the presentation, we'll look at some practical examples of a sequential workflow with inside .NET 3. So when do we use sequential workflow? Well, it's often when we actually know the sequence of activities and they follow a defined sequence. Unfortunately, it doesn't work well when we have unexpected changes within inside that sequence. So it's good for activities that follow a certain script. So it might be to get the data from a sensor, retrieve it back, and then store it. So that is a fairly well scripted series of events, and we can actually define all the flows that are required for this. It doesn't work well when new activities come along or activities happen at different points within inside the workflow. Also, when we have well-known stimulus to our system and that we can catch each of these inputs. So within inside Visual Studio, we get a graphical representation of our workflow with a begin and an end, or a start and end. And then we can have various activities that we can actually drag into the designer. So in this case, we've taken some code activity and pasted it in. And then we might have an if-else activity where we can define what the if-else condition is and branch off one way or the other. So we can see here that this gives us a high level abstraction of our application. Some of the other things that we can have is that we can have delays within inside it. We can have a suspend for our workflow. We can throw exceptions. We can even have some sort of web input service and web output. So when we look at Visual Studio, it typically gives us a series of files. The workflow schematic can either be viewed as a high level abstraction, or we can actually view our code. So in this case, the code associated with this workflow integration is this file here. We just switch between the designer and the code view, and then we have some extra code which will start up our workflow engine for us, and then we have the actual rules defined in an XML format. So for our first workflow, we'll make something very simple. All we'll do is that we'll get some input, say the value of I. So I is part of the class here. We'll enter a value of I. And then once we've read that in, we will actually set an if-else activity so that if it is less than 5, then it will go to down this branch. If it is greater than 5, then it will go on this branch. So basically there's an input, then there is a branch, and then it should actually end. For the branch itself, we typically have a condition. In this case, we declare a rule, and it's if I is greater than 5, it will follow this route here. So the code that we have is associated with each event. So code activity 1 is this one here. Code activity 3 is over here. So if we just switch to Visual Studio, and what we'll do is we'll just open up a console, a workflow console application. So when we start the workflow, we create a new project, workflow, and in this case it would be a sequential workflow that we would actually create. So once we've created that, we should get the designer, and with the designer we can actually drag things into our workflow. So we'll just find our toolbox, which is over here. And so we can get rid of code activity. So just that one, and we can put that back in there. So wherever there is a green dot, we can actually drop that code activity into. And then once we've dropped the boxes, so in this case we would drop in an if else within here, and then we drop in our two code activities. Then inside our code activity we can then define our code. So in this case we still have the code from before, so we can paste that in there, and then we can go back to our designer again, and we can see here there is no little red warning box anymore. So a key place for us is obviously on this branch, and we obviously need to look at the properties for that branch. So I've created one already. So in this case, if we give the condition a name, we can go for a code condition or we can go for a declarative rule. So in this case the condition name is iValue, and if the value is less than 5 then it goes on this branch. If the value is greater than 5 then it goes on that branch. Obviously if the value is equal to 5 then we've not actually caught that condition yet. So the code activity here just defines the value is greater than 5, and then on the other one if the value is less than 5. So we can build this. And we obviously have a little typo here. So we'll rebuild it. And then we have our exe. Our exe should run quite happily on its own, but we'll just run it within a debugger just now. Takes a little while for the engine to start up. Once it's started up, it should give us an input. We input a value of 3, and we can see here that the value is less than 5. So that's a very simple example of our workflow. A slightly more complex one is one that we calculate or determine the number of prime numbers with inside a certain address, a certain range. So in this case what we'll do is that we'll set up a parallel activity this time. So this will mean that we'll have two activities going on at the same time, and then we'll have a while condition in which we wait for the sequence activities to actually complete. So if we look here, we have two array lists for our prime numbers. This one will fill up prime 1, this one will fill up prime 2. So then for our activities, activity 2 searches from 100 to 200 for prime numbers, and then activity 1, which isn't actually on this, here, goes from 3 to up to 100 and finding all the prime numbers that it can. And then what we have is that when these activities complete their task, they will set a flag 1 and flag 2. And then within here we can actually monitor these flags. so that we have some while activity and we wait while these flags are, until these flags are both set to true. Once they are, then we can go to activity 3 and actually print out our prime numbers. So now let's go back to Visual Studio and have a look at this example. So we close down our previous project and now we open up a new console, workflow console application, and we can see here that I've created the workflow already. To have a look at what the rules file looks like, you can see it's defined in XML. The designer looks a little bit like this. This really gets the whole of the engine set up and the basic activities. So there's typically no need to edit this file. The main file that we deal with is obviously the workflow one here. We can have a look at the code or the designer. Okay, so we've taken from the toolbox parallel activity. So this one is dragged on, and then we can actually add on all the activities that we have. And then inside code activity 1, we search through all the prime numbers from 3 to 100, not including 100, seeing if they're a prime number and then adding them into the array list. And for the other one, we will go from 100 up to 200, search for prime numbers, and then once that's complete, we can set the second flag. So what should happen is that we will have a while event, and then once both these flags are true, it will then go into code activity 3, which basically just prints out the number of prime numbers that we have in each of the array lists, and just giving us the end prime number. I've also added a little addition here to be able to define the time it's taken to complete the activity. When we start the application, we set the start time, and then when it's complete, we get the end time, work out the duration, and we can see how long the thread is taken to run. The prime number calculation is quite mathematically intensive, so for large prime numbers it actually takes quite a while for this workflow to be completed. So then we'll rebuild our application, and hopefully we won't get any errors this time. So again, we can easily just run the workflow if we want, or we can run the debugger just to show that it's possible. We'll run the actual application itself in a window. So we can see here that it's managed to find 25 prime numbers in there, from 3 up to 97. And then in the space 100 to 200 it's found 21 prime numbers, and we can see here the time that it's actually taken to actually complete the workflow. It hasn't taken too long for this one, but if we significantly increase one of the tasks, then it will probably, well, it will take much longer to actually complete. Just now we're searching through fairly low numbers for primes, but if we search through a higher space, we can see here that it's taken more than 1 second to actually run that. So we can see that this type workflow is very good for the basic scripting of well-known sequences of events. Often when we use workflow, we don't actually integrate it into our application. What we do is we create a DLL for our workflow, and then the DLL might be integrated into SharePoint or is called from a web interface or from Windows. So in this case, what we'll do is that we'll create a workflow library, and then this will be created as a DLL. We then need to be able to control the DLL, to invoke it, pass some parameters to it, and then get the results back from the workflow. So this allows us to create standard DLL, standard workflows, and to be able to run them across a distributed system. So to do this, we set up an activity library. And so when we compile it, it doesn't compile to DLL, but it will compile to an exe. Then we create our activity. So in this case, the activity is basically just to find the prime numbers between 3 and a maximum number. Then what we'll do is that we'll be able to control it from a Windows interface. And for this, we set up a dictionary of parameters. So in this case, we set up setMax as 400, and then when we activate our workflow, we pass these parameters into the workflow. So setMax is associated with this parameter. So when we set that to be 400, then 400 should be passed into here, which will be passed into the program to set the max variable, which by default is 100, but when we run the workflow now, it is now set to be 400. So then the workflow will run, and then we define the event routine, in which will be executed when the workflow finishes. So the workflow finishes, and then what we do is we get back the primes or the number of primes by calling up this, and then this will return the number of elements in the array list back into primes, and just as a check, we can get the maximum value here. So what we'll do is that we'll create our activity library that will then create a DLL for us. It is important to note the location of the DLL. After this, we can then add the DLL as a reference that will bring the DLL to the place where the exe is and be able to call it up. It also exposes some of the methods and properties of our workflow. So to do that, we add in a reference to the DLL, and then we can access this from our Windows application. Basically what we need is to start off the workflow engine, and in that we define the event routine, which will be called up when the workflow is complete. Then we define the basic parameters for the workflow. So in this case 400 will be passed into this value here and passed into max. This will invoke our workflow with our parameters and start it here. After which we can make it go to sleep for a while until a flag is set. Once the flag is set, then it will come out the while loop and actually print the number of prime numbers that we have. So if we now go back to Visual Studio, so we'll create a new project, and what we'll do is we'll create a workflow activity. And it gives us a new project. We'll just bring up the toolbox here. It's going to be a very simple workflow with just one activity. So we can add in some code here. Let's go to activity 1, And then what we'll do is that we'll just paste in some code that we already have available. Just make sure it's all pasted in correctly. Okay, so we can see here that we have a maximum of 100. We have an array list for our prime numbers. We have a flag to say when it's completed or not. And we just try and rebuild that. And we get no errors. So the key thing for us now is to make sure that we copy that DLL reference, and we can close this project down. So we've created our DLL activity library 2. So now what we do is that we create a new Windows form, and we have one already created. We just move the output here. And one of the first things we should do is that we should add it as a reference. So we just delete a previous reference. So we add reference, and then we can either include a standard .NET component, or we can include our own DLL. It just takes a little minute, and we'll actually browse for it. We'll go to the place where our DLL is, and there it's there. So the advantage with this is it'll take that DLL and place it beside the exe that we have. It also allows us to be able to view any of the elements inside the workflow. Okay, so now what we have is we should have our window. A simple window, we have a simple text box. When the prime is called, the prime button is called, runs the workflow engine, sets up the parameters that we're going to pass to the workflow. Then we can create our instance. So we can see in this case we don't actually have the right reference to it. So it's obviously activity library 2 dot, and we can see here already, because it has a reference to the DLL, we can actually see the class inside it, activity 1 in this case. So then that should call up the DLL when we start it here. We just sit and wait, going around this loop, sleeping for a short time and then checking the flag. Once the flag is set, then it will become true here, and then we can actually print out our values. So we'll just recompile that. Just to show that it's working, we'll add in a breakpoint here, so that when our workflow is completed, it should end up here, hopefully. So show primes, calls the workflow, and we can see here that we've actually managed to run the workflow. It's got a number of output parameters. There's 78 prime numbers, and we can even get the whole array of prime numbers. Stop our breakpoint and then continue. And we can see here the number of primes is 78. So the key focus here is on setting the parameters for the workflow, and then on getting the parameters back from it. So this reference here defines to what the name is on inside the workflow. Now let's look at state-driven workflows. So when would we use state-driven workflows? Well, often we use them when there is some human interaction there, typically when there's a delay in between this interaction. So it could be to send an approval email to a human, and it might be a day or two before they respond to it. It also can happen when we have different flows of activities that occur, and it would be too difficult for us to script all of the activities and become too difficult to abstract. Along with this, we might also have ad hoc transactions which happen as opposed to basic sequential flows. And we also use state-based workflows when there is some external event which is driving or influencing our entities. So we have a high-level state diagram for our workflows. So these define our states that we can be in. Then within inside each state we can have a state initialization. We can also have a state finalization if we require, but this will give us the starting event, the starting procedure for our state. We can set state at any given time, and in this case we set the state to take exam. It's also event driven, where we can have various events, and these will take us off into one state or another. So in this case we've got an initial state, we go into take exam, and then we might have an event where we fail the exam and go here, or we pass the exam and we go to pass exam. So in our designer we might end up with something such as this. We could have a very simple state flow from start message, take an exam, and then mark the exam. We can see here that we have our typical files that we would in any workflow. Okay, so this shows us our initial state, where we have our workflow initialized state. So we go back to our Visual Studio screen, and what we'll do is that we would create our console state, but we'll just start from a starting point here. So our top level diagram is that we would define our three states in this case, and then if we just get rid of our connections, so for each one we can actually define the connection between the states. So we select our event, and then we can actually move to the next state. If we need to, we can move these lines around to help the layout. So in this case we have an event procedure. So we just view our properties. So this is an event-driven activity. This is a starting state initialization activity. So what we'll do here is we'll just set up a very simple flow for starting message, and we can see here that our set state activity is already defined because we dragged that event into the next state. So for our code activity we'll just write a simple message started. Then for our next workflow we need a small delay in there, and then for our code activity we just ask simple question, what's the capital of Scotland, and it goes round the loop until the user enters the word Edinburgh, and it will end the exam. And then when we go to the last part of it, then we can see here that we can actually just print out a message. So we can see this intermediate stage is waiting for this exam flag to be set before it will go to the next state. So if we just recompile that, rebuild it, Okay, so that's worked fine, and then we actually run it. Our workflow is started, and we'll put in London, and that's wrong, and we'll try Edinburgh, and then you can see it's went to the final state there. Okay, so our first state just printed out the message, then went to take exam. In take exam, we defined a delay, a code activity, and because we had already defined our schematic, because we drag from one to the next, our event, our set state is already defined. So in this case, we just ask the user a question, and we wait for a flag to be set before we can go on to the next state. Once we're in that final state, then we can just write a message out. And then once it's completed, then it will stop. So let's look at another example of state-driven workflows. In this case, we'll look at one which has a branch in it between two states. And we'll just load it up here. So in this case, we have our initial state, which will then move on with after showing a message to take exam. Then we get the exam, and we should branch to either failing the exam or passing it. So if we have a look at the basic workflow for the mark exam, so we can have a code activity in here that we can view. And in this case, all that we're really doing is to ask 4 questions, and we add 1 onto the number of correct answers each time we get something correct. And then we have an if-else activity branch, and then for each branch we can actually define the condition. So in this case, if the number of correct is greater than 3, we go to the pass exam state. Else, if it's less than 3, then we go to the fail exam. So in this case, we can look at our top level diagram. If we go up here, up to our top level there. Okay, so we'll just try and rebuild this example. Test that it works okay. Okay, so we have our exe that we've created. Now we can start debugging, making sure it works okay. So first we'll actually get this question correct, and we'll go for Edinburgh, and we'll say that one's correct too, and then we'll get this one wrong and this one correct. So we can see here that we failed this exam because we only got 3 correct. So this has shown us an example of event-driven, of state-based workflow.